Okay, so we're talking about the review for the quiz today. Here's the topics we're going to go over. I've already done those with my kids, so I'm going to start from here. Here is the question. When does order matter? You're giving a list here. Race, if you're doing like a race, a competition, first, second, third place, etc. Okay, that would be one. And somebody just said numbers. I would give you numbers if you're talking about numbers like books that are numbered and you're going to put those books out on a shelf. Because if you put out books on a shelf and you don't think order matters, then all you can do is put them out on the shelf and you're done. You got your 8 books and you put them on the shelf. If it doesn't have anything about order, then what's the point of the question? You know what I mean? Order has to matter if you're talking about books on a shelf. So like volumes 1, 2, 3, 4, 5, 6, 7, and 8. We did a question like that. If you mean like the number 493, like a 3-digit number, that's a good time to use blanks, and I would not use a permutation for like this number has to be at least 500. Well, then I know I don't have as many choices for this first number, and it would be like from the numbers from 0 to 10, if it has to be at least 500, it has to be 5, 6, 7, 8, 9 are my 4 options. 5, 6, 7, 8, 9. I have 5 options for that one. And do you get how this isn't a permutation? Because permutations always go like, 5 times 4 times 3. But this one, if the number has to be at least 500, then can't this digit be anything in the world? So if this can be any number bigger than 500, this can be anything. So I got 10 choices for numbers, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, or 10. And then the third digit of my number can be like anything again, because you can have repeating numbers, like 599 is at least 500. So I got 10 choices for this last digit. All right, so I would not say that that's a permutation question because you're going to want to use the blanks for it, not a permutation. It can't be like, 8p3. That would not work. Because that only works if it's like this, 8 times 7 times 6. So permutation, I wouldn't say that kind of a number question is a permutation. But books on a shelf would be a good one. How about anybody else with a problem that would probably be a permutation question? Did you think of anything else? Yes. Elections, yes. And that's assuming there's like a pres versus president and vice president, because they are different and one's higher than the other. It's kind of like awards, like first place, second place. All right. One more I'll give you. Rearranging letters. Like for instance in the word M-A-T-H. Do you get I can rearrange this? And the order matters. But I wouldn't just say, oh, I have, okay, for instance, let's say, what are the choices for math? I could say A-T-H-M, atom. I can say A-H-T-M, etc. Then the order matters. If the order doesn't matter, then there's only one way to put out the letters M, A, T, and H. But if the order matters, then it's a permutation question. And if it's a permutation question, how many letters are there? 4. And how many do I want to put out? All 4 of them. 4p4. And that does not equal 1 because the order matters. Okay? That would be 4 factorial over 4 minus 4, which is 0 factorial, and that's it. There's no extra thing. The extra thing is if it's a C question, but this isn't a C question. It's a B question. The order matters. So the bottom line is it's 4 factorial, and what does 4 factorial mean? 4 times 3 times 2 times 1. Okay, so a lot of things to know. All right, that's a bunch of things where order matters. How about where order doesn't matter? Can you give me some key words you might be looking for there? What? Yes, in pizza problems, the order does not matter because we don't care whether they put the sausage on before the pepperoni, etc. Okay? Pizza questions is a good one. What else? Yes? Yes, committees, you're looking for order not to matter. I picked 3 of you. It doesn't mean you're first, you're second, and you're third. It's just the 3 of you. Okay, committees is a good one. How about on card questions? Does order matter or not? No, the way we do it, card questions, the order doesn't matter. Because it's like we deal them out to you, and you can pick them up all at the same time and look at them all at once, so you don't even know what order you got them in. So, all right. Okay, good enough on how to recognize them. Then what else do we got to talk about? We've got to talk about when to use those blanks instead of permutations. So let's talk about that again. Problems with restrictions. Like I've got Bob, Sue, and Sally. And I've got these three people. If I said that I have to arrange them, but that Sue had to be first. Well, if I'm going to arrange them, I got 3 spots for them. I would not use permutations for this problem, even though it's arranging. Because if I say Sue's got to be first, how many choices do I have for the first spot? 1. Times how many for the second spot? 2, because there's only 2 people left once I take out Sue. And then the last spot? There'll only be 1 choice because I've already used the other people up. So bottom line is there's 2 ways to do it if Sue's going to be first. All right? I'd like you to try this question with Bob, Sally, and Sue. Figure out for me how many different arrangements are possible if they have to stand boy, girl, boy. Now, it's important whether, I'm getting some of you guys interpreting this different ways. Boy, girl, boy, if you really, really stick to that, do you get how there isn't enough boys to do that? Okay, but what I really meant was every other person has to be male, female. Okay, so I didn't mean it had to be boy, girl, boy. It could also be girl, boy, girl. All right, if it has to be girl, boy, girl, because boy, girl, boy can't even possibly work because there aren't enough boys, then if it's girl, boy, girl, how many choices do I have for this first spot? 2. How many choices for the boy spot? 1. And then how many choices are left for the girl spot at the end? So the bottom line is there will only be 2 ways to do that. Sally, Bob, Sue, and then Sue, Bob, Sally. All right. So use blanks for that kind. Another kind. Problems where things can repeat, like license plates. Okay? License plates, for instance, if I said, how many license plates, let's say that there's this rich guy and he owns a Caribbean island and he wants to have a bunch of houses for his friends to come and stay on the island, and he wants to have little golf carts to drive between them. So you never have to worry about renting a car or anything. You just jump in a little golf cart. And they're like little spots to charge up your golf cart on the island. And so anyway, you can just drive around the island on your golf carts. So he's going to have license plates for his golf carts. And let's keep it simple, right? More pretty if he has only 3 spots on the license plate. And he's going to have it be 2 letters and a number. Letter, letter, number. Okay? If things can repeat, how many license plates can you make? Figure it out. And then billboard it to me once you got it. If letters can repeat, like AA7 is a possibility, then how many license plates can you make? Turn my way when you got it. Okay, I'm just processing here. All right, still waiting for some of you. Rápido, por favor. Okay. Something's messed up. Interesting. Oh, I know what you guys did. Just to clarify, there are 10 number possibilities. It's really common for people to think 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, but what about 0? So there's 10 for that. That's why some of you had a little too small of an answer. So it's 26 times 26, not 25, because things can repeat. So there's 26 choices and still 26 choices. Bottom line answer was 6760. Raise your hand if you had that one right. Awesome. Okay, on to number problems. All right, I'm going to give you one of those kind we were just talking about before. I want it to be a 4-digit number, and I want it to be at least, I want the number to be at least 6,000. How many different combinations are there? If it's a 4-digit number, and I want the number to be at least 6,000. So think to yourself about blanks, because this is not a permutations question. It kind of is, but you can't use the P to solve it. It's a good question. Can it repeat? If I didn't say it can't repeat, then you can assume it can repeat. I just said number. I didn't say any rules about how they can't repeat. Okay, so if it has to be at least 6,000, then this digit has to be at least what? 6. So therefore, now listen to this closely, because this is like the hardest thing on the test. If I say at least, do you get how I mean 6 or 7 or 8 or 9? What are you supposed to do when you have ors? Add. Whenever you hear or, you should be thinking add, and I've got 4 things that could all work, and I'm going to add them together. 6, 7, 8, or 9. Do you get how that's a 4? Okay. Then the rest of the digits, since things can repeat, do I care what comes next? No, couldn't it be anything? And therefore there's 10 choices. Times 10, times 10. So I can do this one in my head. 4 times 10 is 40, times 10 is 400, times 10 is 4,000. Right? All right. How many had 4,000 as your answer? Okay, good. All right, one more. This will be trickier. A 4-digit number. And the number has to be at least 50. A 4-digit number. The number has to be at least 50. Now this one, if you really think about it, is incredibly hard. Actually, well, it's not this. I guess it's not incredibly hard. But if you're gonna just try to do it with blanks, and you're gonna go like this, okay, 4-digit number, at least 50. Well, then what he's saying then is that this 5 has to be at least a 5, and so therefore, or this spot has to be at least a 5, and therefore 5, 6, 7, 8, or 9. So that's 5. Yep, 5 spots. 5 things could happen. But the problem with that is that on other numbers that start with a bigger thing, if you just thought it was this, on other numbers, like how about this number, 6,594, isn't that at least 50? So I can put a 9 in here sometimes. All right, so this would be a really tough question. Does anybody have a different way we could do it then? Think about it. Everything works. That would be all the numbers if anything could work, right? So we actually figure that out. 10 times 10 is 100, times 10 is 1,000, times 10 is 10,000. There's 10,000 numbers then that you could have. But minus, there you go, minus some of them don't work. How many of them wouldn't work? 49 of them? All right. I think this would work, but we wouldn't give you one this tough. All right, moving on. Let's talk about the difference between how many ways and probability. Remember that when it's a probability, you usually end up getting a big fraction, like the CC over C kind of thing. That's if it's a probability. The only exception to that, no, I shouldn't say the only exception, that's a bad word, but a common exception to that is if you're doing binomial. Do you know how, did you ever notice that the binomial ones were probability answers, but we didn't have to divide them by anything? Do you know why? It's because they were like 80% here, which would be like 80 out of 100, and 20% here, which is like 20 out of 100. Do you get that the fraction's already built into the problem? That's why we don't need to divide it at the end. Okay? So bottom line is, if it's a probability, you're going to have to divide to solve it. If it's a binomial equation, like I got 8 shots and I want to see what the probability is making 7 out of 8, that already has the fraction in it, so you won't need to take those binomials and divide them by anything. All right, so how about when you don't divide it? That's when they say, how many pizzas can they make? You get how that's not a probability? It's a big number. And so then, we've already talked about pizzas and cards and those kind of problems, that they're going to be what kind? C or P? Nope, C. The ones where the order doesn't matter. Remember, on a pizza, we don't care if it's sausage and then pepperoni. So C. The order doesn't matter. And then this has 2 separate parts, though. 1 meat and 2 veggies. Well, here's my meats. I have 3 different kinds of meat. And I have 5 different kinds of veggies. See if you can do that one. Give it a shot. How many pizzas can they make if they choose 1 meat and 2 veggies? I'll give you a hint. It's not just 1 C. It's multiple C's. I'll let you figure out how many C's you got to make. All right, got 3 meats, choosing 1 of them. Got 5 veggies, choosing 2 of them. And that's all I have to choose from, so I don't need these. And there's my answer, and what do you do with choices? Multiply your choices. So 3C1 times 5C2. Make sure you know how to do that right now with a graphing calculator. Grab it, do the C thing. I know you could do it by hand, but there's big ones on the test, so make sure you're calculator capable here and you haven't forgotten how to find the C thing. It's under the math menu. Give me a if the answer is a big number, I guess it's not that big, but just make sure you know how to put it in the calc. I mean, hey, it's your life, you don't want to check, that's fine, but all right, get the answers zoomed in upon so I can see what you think it is. And turn it my way. All right, some of you are doing a probability. I did not ask for a probability. All I asked for was how many pizzas can they make. And if you think about it and the answer you think comes out to 0.5, they can only make half of a pizza, that doesn't make sense. Okay, all right, good. Saw almost everybody's. I didn't see yours. Can you turn yours, please? Maybe I saw it and maybe I'm not processing. Okay, I'll get back to you later. All right, so there are 30. So bottom line is, this is not a probability. This is a probability. Given that they're going to make a 3-topping pizza, it doesn't say that it has to be 1 meat and 2 veggies. The point is, it's going to be 3 toppings. Given that it's 3 toppings, what is the probability that it'll have 1 meat and 2 veggies? So you tell them, I don't care, give me any 3-topping pizza. And they'll just make something up. And the question is, what's the probability when it arrives that it will have 1 meat and 2 veggies? All right, this is a CC over C in case you're not catching on here. Pizza questions usually involve C's, and if it's a probability now, it needs this. Figure out how many C's it needs and figure it out. Pause for a second while you're working on that. Okay, so I hope you noticed that this is the same basic problem. Got 3 meats, choosing 1. Got 5 veggies, choosing 2. So what's different about it? Now we got to divide, because it's a probability, by all the things that could have happened, which is that there is a total of what? 8 toppings you could pick from, choosing how many? 3. Remember, that's the total. That's a really commonly goofed up number right there. And remember how I said they would balance? This and this add up to this. Remember that? And then this and this add up to that. Okay, if yours didn't balance, you should have known ahead of time it wasn't going to work. All right. Card questions, pizza questions. Any large group subdivided into many parts can be done like this. CC over C. That's when you use the CC over C thing. It's for card questions, pizza questions, any large group divided into small parts. That's if they're probabilities, of course, because you need the fraction. If there was just how many ways can I make a pizza, then it's just the top part of the CC over C. Okay? Let's do a typical card question. All right, there's 52 cards in the deck, right? What's the probability if I deal you 5 cards that I'm going to give you, 2 kings and 3 queens. 2 kings and 3 queens out of 5 cards. Set it up. Don't even need you to actually multiply it all out. Just set it up. You're not writing. Unless you've already got it done. Didn't seem possible. It's CC over C. Those of you that are stuck, just try to figure out what the bottom C is, which is always the total. Okay, if you haven't memorized this, we are going to have some card questions, but we are going to put up on the board all of the cards that are in the deck of cards. So you'll see them all, so you'll be able to count them up if you have to, and you'll know that there are 52 cards in the deck. How many had the 52 in the right spot? Okay. If you didn't, that's where that goes. On the card question, it'll always be a 52 right there. There's always 52 cards in the deck. We're not going to mess with you by saying this deck is smaller or whatever. Okay, then. How many cards did I say you were going to get? A total of 5. Notice that's the totals down there. Then on the top, 2 kings. Well, what's here? It's all the possible kings versus queens. All the possible kings. How many are there? And I'm choosing 2. How many queens are there in the deck? 4. And I'm choosing how many? All right. Now, some smart kid would say, but sir, you always said these would balance. And that plus that does not equal that. That's because there's all the other cards, and we're choosing 0 of them. Now, we could do that just to make it balance. And then we think there's 52 minus A, is that 44? Choose 0. Do you have to do that? No. But if you want it to balance, then do that. But because it won't hurt, that's just equal to 1. Right now, 44 and 4 makes 48. That makes it 52. Now these actually all add up to 52, just like they're supposed to. And then this and this and this add up to that. All right, I want to do another card problem because I was seeing a lot of people struggling with that one. So let's try that again. Question first.
If you added a 44 to 0, would the answer be different?
You don't want to add it.
Or times it?
Times it. If you times that in there, you get the same exact answer, because what do you think the calculator gives you? If you are choosing 0 of something, how many ways are there? 1. There's 1 way to choose 0. So this is a 1. So when you times by 1, it won't help or hurt you. It'll keep it the same. All right, let's do another card question. So here's a card question. You're going to get 5 cards. I want it to be all 4 jacks. You're going to get all 4 jacks. Figure out what that means. What's the probability you will get all 4 jacks? So, oh, 5-card game. We always do a 5-card game or a 7-card game, because in real life, that's what they usually are. There's also a 2-card game that's pretty popular that, what's that called again? Hold'em, that's right, that's a 2-card game, but 5-card in this case. All right, hope you know it's CC over C. That should be a great way to start, and if you just remember this is the totals, you'll be in pretty good shape to start with. 52 cards, choosing 5. Those are all the totals. Then on the top, I have got jacks, and then did you remember to put not jacks or other cards over there? All right. Then you want, there's 4 of them and you want all 4. Always times your choices together. And then there's 48 other cards, and then how many of those do you have to have? See, some people are going to go 0, and then I would hope you would notice this does not balance. Get what I'm saying? All right, so that has to be a 1. You want 1. I never said anything about the other card, but think about it. I said you were going to have 5 cards, so you can't leave it with just 4 on the top. You have to have 1 of these other cards. Be honest now. How many would have had that one right? Raise your hand if you would have. All right, still only at 3/4 of the class. So I'm going to try one more like that. Okay, try a, let's see. Let's say that you're going to have a 7-card game. What's the probability that you will get 5 clubs? Because that is what's called a flush. And it's a really good hand if you've got 5 clubs. Because you only play 5 at a time out of your 7. And if you can play the 5 that are all clubs, then that's a flush. All right, try to figure out if it's got to be CC over C. In case you don't know these numbers, there's 13 clubs in the deck. For those of you actually typing it in because you're card players and you're curious what the probability is, it's really low. But then again, if you really just want to have a flush, you could do 5 clubs, or what else would work for you to give you a flush? 5 hearts, or 5 diamonds, or 5 spades. And when I said or, you would add them all up. That'd be more complicated than something we would usually do, but so probability of getting a club flush would be this. CC over C, and how many C's are on the top kind of depends on the problem, but there are 52 cards in the deck, and this time we are choosing 7 because we said it was a 7-card game. This is the total is 7, the biggest number of picked cards. Up here on the top we got clubs, and we got not clubs, and we have 13 clubs, and I'm choosing out how many of them? 5 to be clubs, and the not, there's take away 52 minus 13 makes 30. Thank you. And then how many of those do we want? Because if you don't have that 2, this and this won't add up to 7. So how many of you had it right this time? Raise your hand if you did. Now we're at about 100%. Okay, good. Now let's try the other kind. I said a large group subdivided into many parts. Isn't that just what cards is? A big group, 52, divided into like smaller groups. Well, here's a group, whole bunch of marbles. Bag of marbles, red, 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 green, green, blue, 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 blue. Okay, those are my marbles you could reach into the bag and grab. If you reach into the bag and grab 3 marbles, what's the probability that you will get 1 red, 1 green, and 1 blue? It's just like the card question. It's just instead of clubs, spades, hearts, it's red, green, blue. What's the probability if you reach in and grab 3 marbles that you will get 1 of each? You got to think of the big groups as that are subdivided into smaller parts. They're all like card questions or pizza questions. Well, in this case, the total is 4, 5, 6, 7, 8, 9, right? And how many was I pulling out? 3. Notice I start at the bottom. Then on the top, I figure out I wanted, 3 things actually, C, C, and C. Because I have red, green, and blue. And the reds, there's 3. And I want how many? 1. Greens, there's 2. I want how many? 1. Blues, there's 4. I want how many? 2. No, 1. Sorry. I don't know why I did that. Okay. Then this plus this plus this adds up to this. And 3, 4, 5, 6, 7, 8, 9 adds up to 9. Telling you, check yourself on those CC over C's and you can really ensure that you're not screwing it up. Raise your hand if you knew how to do that one. Okay, good. Then, last kind is binomial. And the binomial ones are things like this. Brent makes 85% of his free kicks, so this is soccer. What's the probability he'll make 4 out of 5 then? And then there's a separate question. What's the probability he makes at least 4 out of 5? Well, in case you forgot how these work, you got a C in the front and 2 sets of parentheses. Now, if he's an 85% guy, then he's a 15% misser. This is make, this is miss. Okay, then how many am I trying? 5. How many do I want him to make? 4. 5C4. And then the last thing is I just need a little number here and a little number here for the powers. And how many makes do I have? If he makes 4 out of 5, I have 4 makes and I have 1 miss. Raise your hand if you're comfortable with that kind. Okay, then here's the harder part. What's the probability he makes at least 4 out of 5? Do you remember I said this is really important before? What did I say about at least? It means 4 what? Not and. 4 or 5. He can make 4 or 5. He can't make 4 and 5, can he? It's either 4 or 5. And what do you do with ors? Add them. So, figure it out. What's the probability he makes at least 4, which really means 4 or 5. Figure out the actual answers with decimals. Figure out the grand total, final answer, and then turn it my way. We'll see if you've got it right. I've done the first part for you. That's the probability of making 4. Pause while we work on that. Okay, so this one that we already had with 5C4, 5C4 comes out to 5, and then this times to the 4th power is that, and then that is to the 1 is just that. And multiply them all out, you should have got 0.3915, which I'm going to round to 0.392. Okay, the other one we had was 5C5, 0.85 to the 5, 0.15 to the 0, and I really shortened that up a lot because I know what that's equal to. What's that? 1. If you just type that in your calculator, you're wasting time because a C question just comes out to 1. If it was a P question, that you'd need the calculator for. 5P, 5 is like 5 books. How many arrangements can I have? It's a number. This one's just 1. How many ways can I choose 5 if I'm taking all of them? Well, if the order doesn't matter, if I take all the books, then I've picked them all. I got 1. Anyway, if you're not sure, go ahead and type it in the calculator. It's 1. And then that's some weird number. And then this is 1. So 1 times the weird number comes out to about 0.444. And I said or means add. If you can win, if you get 4 or 5, then it's that or plus that. So I add them all up. 0.8, who's got it? 836? Awesome. Any questions on that? All right. Then I'm going to ask you a tougher one. Same exact problem, same exact kid, same exact percentages. But then what's the probability he makes at least 1? I'm going to see if you're smart enough to figure out not to add up a whole ton of things. Probability he makes at least 1. Wouldn't that mean 1 or 2 or 3 or 4 or 5? Yes, and that's the really slow way to do it. So what's the smart way to do it? Would you agree? He can either make 5, or he can make 4, or he can make 3, 2, 1, or he might make 0. But we want to know what's the probability of at least 1. That would mean all of these added up. Or I could do what? 1 minus that one. Because they're all going to add up to 100%, right? So I could do 1 minus the one I don't want, which was him making none. So if he's going to make at least 1, then he can't have 5 and have 0. This is the impossible one. So I go like this. And he's going to make 0 and he's going to miss all of them. So final answer is whatever 1 minus all that is. Because that's the probability of this. And I can take 1 minus that. Do you get how that was way easier than doing 1 and 2, 1 or 2 or 3 or 4 or 5? You can do it both ways. It's just going to take you forever to do it the other way. All right. I think I have prepared you as well as I can. The homework for tonight is on Schoology, and that's a review, 12.5 to 12.7 review. I hope that's what it's called. Has anybody found it already? Is that what it's called? 12.5, 12.7? It might be called the probability practice. I'm going to check that for you. That's all I got for the video.